All right, so this is section 2.1. The commutative property. You are doing page 67, 1 through 42 even. All right, commutative. Anybody know what that word means? What does it mean to commute? I commute to work. I commuted on the train. What does it mean to commute? Let's go, Lawson. Oh, Xander, sorry. What'd you say? To travel. It does. It's exactly what it means. To travel. I hear a lot of paper flipping. That should be done before the bell rings. Okay, so to commute means to travel. And that's exactly what happens in the commutative property. In the commutative property, the order doesn't matter. Okay? The order, we can just, as long as we have the commutative property of addition. Okay, one more time. This is section 2.1. So in the commutative property, the numbers move. The order doesn't matter. It doesn't matter if I add 1 plus 2 or 2 plus 1. The order of the numbers, if it's a cross addition, it's going to be the same value. 5 plus 7, 7 plus 5. A plus B, B plus A. The order does not matter. And when it's over an addition sign, we call it the commutative property of addition. What do you think the commutative property of multiplication looks like? Jared?
Let's say, for example, A times B, it will be equaling B times A.
Right. A times B equals B times A. Or more often you'll see A times B times C equals C times B times A. Or C times A times B. The order doesn't matter. We use it a lot when we're doing mental math. We use this property. We do it automatically. We just haven't put a name to it. So if I have 2 times 3 times 5, more often than not, I do 2 times 5 is 10, times 3 is 30. Because it's easy for me to multiply my tens in my head. Does that make sense? Yeah.
I'm also wondering, can you record that?
Yes, it's all getting recorded. Oh, okay, thank you for being my reminder. Okay, so 8 times 4 is the same thing as 4 times 8. So the one thing that I was like looking at here was, let's say I had 2 times 48, or let's do this, 2 times 45 times 5. I like to do 2 times 5 times 45 because that becomes 10 times 45, and that's 450. Does that make sense? Do you see how I move the numbers around in my head so I can do some mental math? The order doesn't matter. That's the commutative property. Okay, questions? Can I erase that? Okay. Okay, so now the one thing you got to know about the commutative property, let's look at addition, and addition and multiplication are commutative. Is subtraction commutative? Yes. Okay, and the way we do that is with something called a counterexample. A counterexample. A counterexample proves something false. proves a statement false. So, the counterexample to this subtraction being commutative is 8 minus 5 the same as 5 minus 8. Sabina? Why? What does that equal? 8 minus 5 is 3 equal to negative 3? No. So you can see, that's one way to prove things false with a counterexample. With addition and multiplication, you just have to show an example. It's either all over addition or it's all over multiplication. It wouldn't be mixed. Does that make sense? It's not going to be like 3 plus 2 times 5. It has to be completely over addition or it works completely over multiplication. Now, is division commutative? What do you think? Let's try it. What is 4 divided by 2?
2.
And what's 2 divided by 4?
Negative.
No, it's not negative. Look. Oops, I didn't mean to do that. 4 divided by 2 is what? 2. And 2 divided by 4 is what? What does that equal when I simplify it, Ryan? 0.5 or 1/2. Are those equal statements?
No.
So it doesn't work. All you need is one thing to prove it false to say that that's true in math. So all you need is one example, one counterexample to prove something false, and then that's a false statement in math. This is not equal. Okay. So division is not commutative. So what does a commutative property work with? What operations? Haley?
Multiplication and addition.
Multiplication and addition only. Okay, state whether this situation below is commutative. Yeah, do you want me to go back?
I just have a quick question.
Mm-hmm.
You know, like for the equal sign and the slash, we do that on our homework, right? Whenever it's in.
Well, they're not going to really ask you that. They're going to have you using the commutative. But that means not equal. That means not equal. Okay? All right, so now let's talk about each situation, whether it's commutative or not commutative. Is waking up in the morning and going to the school commutative or not commutative? You can't switch it around and it'll be the same. I can't go to school and then wake up. Right? Your teacher be like, why'd you bring your bed to school? You know? Like that grammar of mine. Okay, brushing your teeth and combing your hair, is that commutative?
Yes.
Yeah, order doesn't matter there. Putting on your socks and putting on your shoes.
No.
You'd probably look like a fool. Okay, eating cereal and drinking orange juice.
Yes.
That's commutative. So do you understand the order in commutative? It doesn't matter what goes first, what travels to the first place or to the second place. Okay? All right, associative property. This is my fun one. This is where regrouping is okay. You can regroup the numbers together. I'm going to put the recording on pause. I don't know how I can get that. Okay. So with the associative property, what happens is the group changes. Let's look at it with letters. Who's hanging out in the first group?
A and B.
Okay. Notice on both sides of the equal sign, the order is the same. It says A, B, and C. A, B, and C. What changes is the group. On Friday night, A and B are hanging out. And on Saturday night, the group is B and C. So that's the associative property. The group changes. Okay? Oops, that's not what I meant to do. Okay, so if I had numbers, who's hanging out on the left side of the equal sign?
4 and 2.
And who's hanging out on the left side? And the order doesn't change. Okay? Now, with the associative property of multiplication, the only difference is it's multiplication straight across. A times B times C versus A times B times C. But the group in the first one is A and B, and the group in the second one is B and C. Here's an example with numbers. We do this, I do this a lot when I'm doing my mental math. Remember when I said 2 times 5 times 45, or 2 times 45 times 5 is easier to do than, 2 times 5 times 45 is grouping 2 and 5 versus 5 and 45. Let me write that down. This is what I meant. If I have two times, let me do this. 2 times 5 times 45 is equal to, same order, but I'm grouping this way. 10 times 45 is easier to do than 5 times 45. 5 times 45 I can't do in my head. 2 times 5 is 10. 10 times 45 is 450. I can do that in my head. That's why I use the, what property is this? Now, what operation do we see? So this is associative of, this is associative of, okay. Oops. Questions?
So
Yes.
it doesn't matter about the, let's say the numbers for the associative property of multiplication. It doesn't matter about the A and the 3, what order, it just matters if all
The order stays the same.
Yeah.
It's only the group that changes. And we can change the group by just moving the parentheses. I'm just moving my parentheses. Okay, so now let's look at counterexamples for subtraction with the associative. Let's see if this is the same. If 10 minus 3 is the group, what does that equal?
7.
That equals 7, right? So now, 7 minus 2, what does that equal?
5.
Okay, as opposed to, where's the group here? Is 1, what does that simplify to?
9.
Is that equal?
No.
So we have just shown a counterexample to prove that it does not work with subtraction. It only works with what?
Addition.
You got it. It only works with addition and multiplication. Okay. And what about division?
Okay.
16 divided by 8, what is that?
2.
2 divided by 2 makes 1 versus, what do I do first on the right-hand side?
8 divided by 2
Is 4.
divided by 16.
What does that come to?
4.
And that is not equal. So if they ask this kind of statement, yes, you would use the not equal. You would simplify and keep going. Okay? Can I erase? So the counterexample proves that division is not associative. Okay? Okay, now be careful here. Things can get tricky. Why is this commutative and not associative? What's happening here, Jasmine?
Because you flipped the order of the 2 and the 7.
It's the same group, just the order changed inside there. So the group is the same, that's why it is commutative. Now, why is this associative? Ange?
Because they're in a new arrangement, kind of.
A new group.
Yeah.
Okay, new group. In the first one, who's hanging out?
2 and 7.
And in the second group, who's hanging out?
7 and 8.
So that's why it's associative. Okay. Now, this is really tricky. Is this associative or commutative?
Commutative.
Why?
Because the 2 and the 7 stay the same.
It's still the same group.
It just moves to the other side.
Right. Just this whole thing switches places with the 8. Do you see that? So it's really still, even though the parentheses are over here, the group is still the same. That's why it's commutative. Okay, next one. Just because name the property. Name the property. Pause the recording and you do the next few. All right, Issa here. Number 1. Perfect. Commutative of addition. Number 2, please. A set.
Associative of multiplication.
Perfect. Number 3, please. Lawson. Xander.
Commutative of multiplication.
Commutative of multiplication. Good. And number 4, please. Angela. Associative of what, Micah? Number 4.
Addition.
Associative of addition.
The associative of addition.
Wait a second. Is that correct? Who's hanging out in the first group?
4 and 2.
And who's hanging out in the second group?
2 and 4.
So what property does that make it?
Commutative.
Commutative of...
Addition.
I get in a little zombie mode where I just keep going. Okay. Understanding? Thumbs up if this is clear to you. Thumbs down if it's not. Pedro, what's confusing? Tell me what you think.
The thing for me that's confusing is I get how to determine and everything, but how do you tell the difference between them?
You have to be able to identify the group. And it's all about the group. Every time you say, who's in the group? And you got to know that commutative travels. The order's changing here. So this is order. So you just get, you got to do a lot of practice with it. The order's changing here. So what's changing here? The group or the order? The group. So that's associative. What's changing here? So that's commutative. What's changing here? Order. So it's commutative. You have to ask yourself that question every time. A few more. One more. All right, here's how we use it in math. Here's how we use it in math. Now, your homework tonight, you're going to have to use a property and state what you're using. Now, look what I'm going to do. I've got 27 times 37 times 4. Here's the thing, I love 25s. They remind me of quarters. So I'm going to do this. What did I do in that step? Please write this down. What did I do in that step? Okay, so is that commutative or associative? That's commutative of multiplication. Okay, now look what I'm going to do. What did I use there? Angela? Associative of multiplication. Now, why did I do that? Why did I do that? Amanda?
Are you saying why you put the 24 and the 4 together?
Why did I put them together?
Because you said that 25s are cool. I mean, not cool, but like they're easy.
They're easy to mental math. So 25 times 4 is 100 times 37, and that makes 3,700. So here I use my commutative property of multiplication and the associative property of multiplication so that I could do mental math. I think we do that all the time naturally. What I think we don't do is name what we're thinking about. Does that make sense? So you try the next one. Can I erase what I've written here? Okay. So you try the next one. Okay. Take a minute and see if you can use the commutative, use the associative to make it more mental math-like.
For number 2, do we switch those 2, or is that supposed to be only multiplication?
Number 2 is only addition. You can see it. You can't change the operation sign. You can switch the group and you can switch the numbers around. But you cannot switch the signs. Switch it around so you can add it up easier in your head and do mental math.
Are we supposed to solve it?
Simplify it. We solve when there's an equal sign. And I want you to name the properties you're using as you go. Okay, who would want to start this one? Angela. This Angela, sorry.
First, I would do 29 plus 8.
You're adding those together?
Oh, wait.
I want you to use the properties to make it simpler. So what property can I use first to make it simpler for me? Jasmine.
I would use the commutative.
Okay, and so how are you going to do this?
So 12 plus 8, and then, yeah.
12 plus 8 plus
29.
29. Okay? So there I use the commutative property of multiplication. Next step. Next step. Angela, what would make this easier for me to do some mental math?
You could do 12 plus 8, and then plus 29, but you would use the associative property.
And put,
Put 8 plus 12 in parentheses.
good. Okay, so that is Which property?
That's
Associative of multiplication. And now 12 plus 8 is 20 plus 29 simplifies to, isn't that much easier? I don't have to regroup. So now I've just used my properties. Okay? Next, more properties. We've been doing these for a while. Do not put your stuff away. You need to write these properties down. This clock is fast. Okay. Identity property of addition. When I start out with an x, what is the only thing I can add to it that will not change its value? I can add a 0. And I still get the same identity, x. So what I start with is what I finish with. That's the identity property. Since I add 0, that 0 has a special name. We call it the additive identity. Okay? The identity property of multiplication. What is the only thing I can do to x that will give me the same identity in the end? X in the end. X. What can I multiply it by? Ryan? By 1. Now they get tricky with this. Out. Stop. They get tricky with this. They might show you something like this. What does that equal?
1.
It's just a fancy 1. They get very tricky and they show it to you with fancy 1s. Okay? Now, properties of 0. We've been doing this since probably 2nd grade when we learned our multiplication tables. The multiplication property of 0, or the 0 product property is what we call it in algebra. If anything you multiply by 0 has to equal 0. Okay? And the division property of 0, well, you're never allowed to divide a number by 0. So if you see yourself, whoops, I meant to go back. Hold on. Okay, if you see yourself with a fraction and zeros in the denominator, it's never allowed to happen. It's one of my 10 commandments of math. Thou shalt not divide by 0. Hold on. Shh. I'll wait till you're ready. Still going. Okay, number 1, really quick. Shh. What property? Raising a hand, a quiet hand. Shh. Sabina? Good. Number 2, please. Angela?
Commutative property of multiplication.
Good. Number 3. Quickly. Jared?
Associative property of multiplication.
Of addition. Okay, let's go down to number 4. Number 4, Haley.
Associative property of multiplication.
Good. Number 5, Sabina.
Multiplication property of 0.
Good. Number 6, Aset.
Addition property of 0.
Not addition property of 0. Identity. What you start with, you end up with. Okay, and what about this one, number 7? Micah?
Identity property of
Multiplication. Good. And that's our lesson.